Hello, welcome to today's lesson. Today we're going to be learning about Pythagorean theorem and setting it up in using real-world problems. And then we'll also be using the converse of the Pythagorean theorem to classify triangles as right, acute, or obtuse. Now, by the end of the problem, we'll be doing word problems using the Pythagorean theorem. But before we get to that, let's think about this. Um, the measures of these sides, let's say will eventually be in centimeters, but if we have A, B, and C, we know if it's if it's A squared plus B squared equals C squared, we know that definitely makes a right triangle. We- Um, that's the converse of the Pythagorean theorem. If it's right, then that works. Also, the other way. Now, if it's greater than or less than, we have to think about what happens. Well, over here is an obtuse triangle, and over here is an acute triangle. And let's see what happens. Well, if I just plug in some numbers, if I have 3.7 squared plus 5.5 squared, and I want to see if that's equal to 7 squared. Well, first thing you do is grab a calculator, and unless you know 3.7 squared off the top of your head, and then you add that to 5.5 squared, and then you get 43.94. Now 7 squared I do know is 49, and that's not equal to 49 is bigger. So if a squared plus b squared is less than that, that creates an obtuse triangle. And I like to think of it as C is so big that it makes uh, the triangle obtuse. So now if we did an acute triangle and we did 3.8 squared plus 4.9 squared and seen if that equaled 5.4 squared. If we have 3.8 squared plus 4.9 squared, that equals 38.45, and 5.4 squared is 29, so that's, oops, uh, greater than 29.16, and so if it's greater than, then it will be an acute triangle. And I like to see it that C is not big enough, so it makes it acute. So these are some examples for you to try. What you have to do is you have to take the two smallest ones. In this case, 5 and 7 are the two smallest. So we'll say 5 squared and 7 squared and see how that relates to 8 squared. Well, we have 25 plus 49 and 64. 25 plus 49 is 74. Since 74 is bigger than 64, this isn't big enough, so this will be an acute triangle. Now it gets a little bit more complicated here. The square root of 61 is 8 point something. 2 root 5 is 4 point something. And so, well, these are the two smallest sides. So 2 root 5 squared plus root 61 squared is going to equal 10 squared. Now you could just plug this into your calculator, and that would, but if you do it without a calculator, it'd be 4 times the square root of 5 times the square root of 5 is 5. 4 times 5 is 20. Square root of 61 squared, these two undo each other, and that'll just equal 61. And then 10 squared is 100. Now, this side is so big, it's going to make this triangle obtuse. Now, our last one, uh, 11 is bigger than 9. So, and square root of 17 is a much smaller number. So this is going to be our C. So we'll do 9 squared plus root 17 squared is equal to 11 squared. So that's going to be 81 plus 17 equal 121. And so that will be, what, 98? And that's much less than 121. Since that C side is way too big, this would be an obtuse triangle. All right, hopefully that starts to make sense for you. And now we're going to do some real world problems, or other learning objective. This one says the distance between each consecutive base in baseball is 90 feet. Determine how far the catcher has to throw the ball to get from home to second base. All right, now if here's your baseball diamond, each side here is 90, and they meet at a right angle, and that base looks like it has a nice perpendicular mark in there. Now to find this distance, what we do is we take 90 squared plus 90 squared equals c squared. Now 90 squared is 8,100. 90 squared is 8,100. And when you combine these together, it's 16,200. Now, in our previous chapters, we were simplifying the square root, but when we're doing real world problems, typically we don't simplify square roots. We actually find the decimal. So c is equal to 127.27 or 28. All right. All right, next problem. Jose has locked himself out of the house. Fortunately, he did leave an upstairs window open and does have access to an extension ladder. The ladder, when fully extended safely, will extend to 18 feet. For optimal safety reason, he wants to put the base of the ladder 9 feet from the house. How high up on the house does the ladder reach? A follow-up question, if the open window is 12 feet from the ground, will he be able to get in? Well, our ladder here, fully extended, is 18 feet, and he keeps it 9 feet from the house. So now he just needs to find this height. Now we use Pythagorean theorem, with 18 being the hypotenuse. So 9 squared plus x squared is equal to 18 squared. 9 squared, you know, is 81, where 18 squared is 324. Now I subtract 81 from both sides to get an x squared equal 243. Now I square root that answer to get x equals 15.588. All right, let's try another one. Then this is our success criteria. Mary wants to buy a computer monitor that is 22 inches. That's the length of the diagonal. She found that a monitor is on sale that's 16 inches by 10 inches. So 16 by 10. Will it fit in her cabinet? So monitors are measured from corner to corner. So I'm going to do 10 inches plus 16 inches. And so to find out the distance, so that's going to be 100 plus 256, and that's 356. And when I square root 356, I'm going to get C. So the square root of 356 is 18.87 if I round. And so will it fit in the 22-inch cabinet? Yes, it will fit. All right, hopefully you understand your learning objectives. You can rate yourself of understanding between 0 and 5.